Okay, so we're going to talk about complex conjugates here. So remember when we had something like 1 over 2 plus the square root of 3, and we said, oh, you have to rationalize the denominator. So we talked about conjugates and how you would multiply by 2 minus the square root of 3. So I don't know if you remember that. That was earlier in another chapter. Anyway, these were conjugates, right? And what it allowed us to do is to eliminate that square root in the denominator. Okay, so that was great. So this is the same idea, but we're using complex numbers now. And there's going to be an imaginary part. So when we go to divide, we're going to need to use complex conjugates. Okay, so let's see what happens. Let's say you have a plus bi, right? That's the standard form for a complex number. And you're going to multiply by its conjugate, a minus bi. Well, when you do that, you're going to FOIL it, and you're going to get a times a, which is a squared. And then you're going to have minus abi. And then you're going to have plus abi. And then you're going to have minus b squared I squared, right? Okay. Now I'm going to have the a squared. Those are going to cancel out because you have a negative abi and a positive abi. And then the I squared here is going to be negative 1. So it's going to wind up being plus, because you're going to have the negative here and the negative here. So plus b squared. Okay. So this comes to a conclusion here, that when I have a plus bi, a complex number, times its conjugate, a minus bi, that is just going to equal a squared plus b squared. Now, a lot of times I get students that just like to FOIL it out. It's easier for them to understand. They're used to FOIL, and that's just how they do it. But you can use the formula as well. Also, multiplication is commutative, so I could switch it the other way, but I would get the same thing. So switching, the factors there. Okay, so just quickly on complex conjugates. So let's say you have 7 plus 3i. Well, then the conjugate is going to be 7 minus 3i. And let's say you have negative 6 minus 2i. Then the conjugate's going to be negative 6 plus 2i. Okay? So I can't think of anything else. Oh, what if you just had a pure imaginary number, like negative 5i? The conjugate is 5i. Because think of it as like 0 and 0 plus, 0 minus and 0 plus. Okay, but that's just like, that doesn't come up a lot, but sometimes it does. Negative 5i, the conjugate would be positive 5i. All right. We're going to use this for division, which we'll do in the next video.